Yeah, hello everyone. This is Team Bias. SkinLens is the name of our app, your personal dermatologist. This is the logo of our app. So this presentation is at the end of sprint one. So this presentation summarizes our team's work done in sprint one, and the agenda of this presentation includes roles and responsibilities, improvements that were done after professor's feedback in sprint zero presentation, and it also includes problem statement, project description, team working agreement, and three different personas. What is our MVP as of now, and we developed a Figma project design and the technologies, algorithms, as well as six different diagrams, and the entire project backlog, as well as focusing on this sprint. We have stories that we decided to do in sprint one and test cases about these user stories and the stories in the sprint one which we were able to complete and which we were not able to complete, and as well as sprint one metrics like velocity, the burn down charts, as well as the committed ratio, and uh, finally after the after entire uh, work at the end of this sprint, we had a retrospective meeting, and we discussed about what we did right, and if we were to do it again, how differently we would have done it, as well as based on this, we took some action items, as well as we decided what user stories we are going to work on in sprint 2. And at the end of this presentation, uh, we will also show a project demo uh, accordingly to the user stories. Yeah, so moving on to roles and responsibilities. I am Mohammad Zaid, team leader and developer.
Hello
Leslie.
everyone, where it's me. Hello everyone, my name is Joan Yin and I'm Scrum Master and also developer.
Hi everyone, I'm Naganjali Pujita. I'm a developer and DBA.
Hi everyone, myself Mohammad Tanzir Bilal. I'm a developer and a tester.
Hi everyone, my name is Bang Yin. I'm a developer.
Hello everyone, my name is Abhikumar Patel and I am a developer and tester.
Yeah, so moving on to the feedback provided by a professor. What professor mentioned is to include an option so that he can send an email to all the team members at once. So we already added this to our wiki page, and what other suggestion he gave us is in Sprint Zero retrospective. What we did is we created three sections. First was what went well, second was what went wrong, and third was action items. He told us to change the second section from what went wrong to if we were to do it again, how would we do it differently? So we made these improvements. Yeah. So just to summarize, what problem are we going to solve? According to World Health Organization survey, like around 9 million people face skin related issues at one time. Though this number is quite high, unless until there is some significant health issues, not much efforts are put in to diagnose it. So accurate and timely diagnosis of skin disease is also a challenge because of two main major reasons. First being limited availability of dermatologists in underserved areas, and as well as the traditional method primary involved only visual inspection of the skin, and this may have human error as well as variability in interpretation. So what is this problem affecting? Who is it affecting to? So what does it affect is this results in delayed diagnosis, limited personal care, and possibly worsening of skin conditions. Yeah, so what's the solution then? SkinLens. SkinLens is our solution to the problem we just described. So project description was SkinLens is a web-based platform designed to provide fast and accurate diagnosis for skin conditions using deep learning. The platform is intended for patients who want to quickly access their access to the diagnosis and treatment recommendations, as well as it is intended for dermatologists who need efficient access to patient reports. And how is it different from the other apps that are already available in the market? Like unlike traditional methods, that solely rely on visual inspection, SkinLens utilizes an advanced image-based deep learning model, that is the image classification model, to offer precise predictions and treatment suggestions. And one of the key features is real-time consultation with dermatologists that will allow patients to receive personalized care directly through our platform, as well as moving on to the benefits. Uh, SkinLens offers several benefits, like including improved diagnostic accuracy, faster and more personalized care, greater accessibility, like just upload an image, get the result. So it has a great accessibility, and it also reduces the consultation costs and real time. It also provides real time access to professional consultation. Can move on to the next slide.
Okay. Hello everyone. This is our team working agreement. As we shared last time, our agreement contains communication expectation. We will use Slacks to communicate, and we respect every ideas and opinions in the teams, and we should focus on the issues, not individuals, when we have conflicts about these things, and also something about the meeting structure, like how often and where can we have the meeting. We will use Zoom, and we have a spring planning meeting, sprint retrospective meeting, and the daily scrum meeting. And if we have anything can't be solved very quickly during the daily scrum meeting, we will plan some follow-up meeting. And this is our team norms and value. It's like about how we take responsibilities in our tasks, and what is our definition of done. The details of the definition of done is here, and how we work together and achieving the goal, and then about our continuous improvement, we encourage team members to reach, to learn, and share ideas with all the team, and we reflect on the feedbacks during the retrospective, and we take actions to improve it in the future sprints.
Hi everyone. So now I'm going to talk about personas. We have three personas, like patient persona, parent persona, and doctor persona. So now I'm going to talk about patient persona. So here is a busy professional person. Her name is Nashley Pagiroli. So she is living in the city, and she has sensitive skin, rashes, acne, like that. So challenges she faced is she has some skin issues, and often it's experiences to delay in appointments with dermatologists, and she finds very difficult to describe about diseases, and she'll be like she wants like fast treatments, and her goals is like she wants a reliable, easy flat platform like our app, and I hope to receive like a treatment in the home only, or like her skin type, her age, like that. So coming to like parent persona, coming to parent persona, her name is Gloria Garson. She is a housewife and she has the 4 children and with husband, and she'll take care of household duties, um and little bit she has to focus on her individual health. And challenges she faced is like she frequently she'll be like delays, minor skin issues like rashes, eczemas among her kids, and she's like totally confused about different ages and skin types. So goals she wants like maybe she save time by using images and she uploads in our app, and she wants peace of mind by receiving accurate and clear advice, and things like a home care is sufficient, like. Yeah, so coming to doctor persona, yes. So coming to doctor persona here, here is a like Dr. Robert. So he is working in both hospital and the private clinic, and he every day he's treating like a high volume of patients with various skin conditions. So challenges she faced is like he has to manage large patients load daily, and he wants like um he doesn't have a limited time to check um each and every patients, and he often like receives incomplete descriptions of diseases, and he's challenging to diagnose accurately without further testing or follow-ups. And goals he wants a platform of patient information, including images and medical history, like that. And he'll be like he'll aims to reduce the patient times too. Yeah.
Okay, for our MVP, we are focusing on 3 key functionalities: patient image upload, AI power diagnosis, and diagnosis displays. Patient will have the ability to upload images for their skin condition directly through the website interface. This step is crucial because it allows us to gather the necessary data for diagnosis. And the course of our project is an AI-based image classification model. Once an image is uploaded, our AI model will process the image and analyze the condition. After processing, the platform will show the patient the diagnosis results. These results will help the user understand their skin condition and receive further instructions or recommendations. Okay, go next. Okay, here the picture is our project design. As you can see from the image, we've designed a simple and intuitive interface with a focus on our user experience. This is the homepage where users can begin their journey by clicking the button "Start Your Test" in the center. The layout clearly guides them through the process of skin diagnosis. I'm gonna explain the features. At the top of the screen, users can navigate through various features, including options to upload images, make appointments, and use the chat function for support. These options are clearly visible, ensuring the user has easy access to different services. And the main call to action is to start your task. This button stands out in the center and invites the user to engage directly with the platform. And below that, we've included a through-step explanation of the process. And one is upload image, and the other is AI analysis, and last one is get results. Okay, let's go next. Here is the technologies we use for our for the spring one of our project. And first, for the website, we used Figma to design the interface and implemented front-end with React and JavaScript, incorporating a CSS library for styling. On the backend, we use Python with the Flex framework, and also including Node.js as a library. Firebase serve as our database. For the model, we are building an image classification model using TensorFlow and Python, along with Keras libraries. Initially, we trained the model using Google Cloud, but for large-scale image training, we will deploy the model on Google Cloud Platform using Docker and Kubernetes, especially through the GKE services. Throughout the project, we use Slack for communication. All code is pushed to GitHub, and we rely on Jira to plan and check our progress. Our preferred IDE is VS Code, and we utilize HubSpot for API testing.
Yes. So coming to our front end, we use like React plus Vite and Tailwind CSS. So what is React? So it is an open source JavaScript library, and it is used to create interactive and reactive interfaces, and it can split like UIs in reusable components, like, and we can build like a large amount of web applications. And Wait is like it is a fast and good web application build tool, and it is used to stand out for its fast startup and instant compilation times during development. And coming to Tailwind CSS, it is an open source CSS framework, and it is used to styling our app or application. Yes.
So, moving on to the backend structure of our project, this basically utilizes the backend Flask server, and in our project we used Flask, which is basically a lightweight Python web framework to develop backend and create the required necessary API endpoints. Why Flask? That's one main important question. Uh, Flask because it efficiently handles routing for key functionalities like image uploads, as well as if you want diagnose retrieval. Basically, what it does is it acts as a middleware between the front end and the image classification model. It also integrates easily with Firebase, allowing us to store and retrieve images and diagnosis reports. So now our front end is on a React plus White, and our back end is on Flask, and both of these run on different ports. So there should be a way to to allow requests from the front end to go to the back end and so on. So to handle security, we configured CORS, that is cross-origin resource sharing. This basically ensures secure cross-origin requests between our React front end and Flask backend, especially like because they are hosted on different domains. And for this, we used Flask CORS extension to manage this, specifying the allowed HTTP methods and domains. And on the front end, we implemented Axios, which is a JavaScript HTTP client to manage the API requests, like uploading images and retrieving the diagnosis. Uh, why Axios? Because Axios simplifies API calls and it also supports asynchronous operations, keeping the app responsive as in till the API fetches the data, we can do on other work. So additionally, Axios provides built-in error handling, which ensures our app remains robust and user-friendly, even if there are any network issues. Yes, you can go on to the next slide. So this diagram basically shows how Course and Axios are functioning in our app. And on the top left corner, you can see patient. Patient can select and upload an image of their skin condition via the React web app front end. And then Axios, which is the HTTP client, the front end uses this Axios to create a HTTP post request, which contains the image file. And then the Flask API backend, the Axios basically sends requests to the Flask backend, which checks course policy to ensure whether this domain is allowed to send a request or not. And what is course policy? Yeah, the Flask API checks basically, yeah, Flask API checks and approves the cross-origin request. Uh, and the backend stores the image in Firebase storage after the course validates. After the image is successfully uploaded, the backend sends a response back using Axios, which handles it by passing success message to the front end. And displays the success message to patient indicating the image upload was successful. Yes, you can move on next slide.
Yeah, hi everyone. Now I'll speak about the algorithms which we have used to train our image classification model. We have used TensorFlow and Keras for the CNN model and data augmentation. We have used OpenCV library for image pre-processing and Matplot library for visualization. Next slide, please. Next slide. So let me just give an overview of CNN architecture. It is designed to extract features from input images of skin diseases and classify them into one of categories of the five classes which we have used using a combination of convolutional pooling and dense layers along with techniques like dropout and batch normalization to ensure efficient and accurate learning. So let me just give the overview of layers which we have used. Convolutional layer. These layers extract features like edges, textures, and shapes from the images. Max pooling layer. These layers reduce the spatial dimensions of the feature maps, making the model more efficient and reducing overfitting. So batch normalization, it normalizes the output from the convolutional layer to stabilize and accelerate training. Dropout layer randomly sets some neurons to zero during training to prevent overfitting. Like We have used dropout as 0.5, which reduces 50% of the neurons in this layer to zero during each training step to prevent overfitting. So flatten layer, it converts the 3D feature maps into 1D vector, preparing it for fully connected layers. Dense layers, the final output layer that classifies the images into one of the classes using softmax activation. So the reason why we preferred Adam Optimizer is one, it combines the benefits of momentum, which is faster convergence, and RMS prop, it is adaptive learning rates. Two, Adam dynamically adjusts learning rates, making it more robust in practice, especially when dealing with complex models and datasets. Also, it helps to overcome early bias problems in gradient estimates, leading to better early stage performance. Also, Adam generally works well with its default hyperparameters, making it easier to use without needing extensive tuning. And the loss function we have used is categorical cross entropy, which is for multi-class classification. So next slide, please. So let's talk about diagrams, architecture diagram. The patient uses the UI, which is built with React, to upload the images of the skin condition or to communicate with a dermatologist through chat service. The UI then sends the image and patient data to the backend Flask API. The Flask API processes this request and interacts with the AI model to predict the skin disease. Then the AI model processes the images and generates predictions. Then the Flask API then sends back the result to the front end for display to the patient. Also, all images, case details, and chat conversations are stored in the database for a future reference and record keeping. And we are using the real-time communication in order to engage in real-time chats with a healthcare provider where the chat data is recorded in the database.
So this slide has a detailed architecture diagram. It looks quite messy, but let me just explain it. This diagram shows the architecture of our SkinLens project and how different components interact with each other. Starting with the patient, they use the React web app to upload images of their skin condition. And then these images are sent to the Flask API in the backend, which then forwards these requests to our model for diagnosis. And once the model processes the image, the diagnosis result is written back to the Flask API, which stores the diagnosis and patient information in Firebase Firestore. And it also stores the image in Firebase storage. And then the React web app displays the diagnosis back to the patient. And additionally, patients can request real-time chat with a dermatologist through React web app. The app communicates with the real-time chat service to initiate this session, while chat messages are stored in Firebase real-time database. The dermatologist can access the patient's case and participate in the chat via same web app using his dashboard. And this setup ensures like a seamless interaction between the front end and back end, which allows efficient image analysis and secure data storage and real-time communication between patient and dermatologist. So this was just a clear walkthrough of the system's workflow. You can move on to the next slide. Bangling.
You're muted.
Sorry, it's Mel. So the contact diagram gives us a clear overview of how different components of the system interact. And the patient can upload the image to our web, and then the patient display, it means that the image gonna upload it and confirm the request and also display the diagnosis. And then the AI model can process the image and then give the diagnosis results. And next, the database is gonna store the data and the image file and diagnosis results. Also, the doctors can add review and also can assess cases to provide any reviews or any comments to the result and show the patient. Yeah, you can go next.
Muted.
Sorry. So this is the sequence diagram. This sequence diagram outlines the interaction between patient, dermatologist, the SkinLens web app, the image classification model, and the database. First, the patient registers and log in, and their profile is stored in the database. After logging in, the patient can upload images of their skin conditions, which are sent to the image classification model for diagnosis. And the diagnosis result is written and stored in the database and then displayed to the patient. The patient can also view a comprehensive report of their case, and this report will include all the details like all the diagnosis details and treatment recommendations which is retrieved from the database. And if the patient requests a real-time chat with dermatologist, the app facilitates the chat, and during the chat the dermatologist can add comments and update the diagnoses which are stored in the database and reflect in the patient's report. And the patient can download this comprehensive report of their case, and the dermatologist can log in to view and update patient report. The dermatologist profile and activities are also stored and managed by our system. Yep, that's it. This is how the workflow is.
Okay, everyone, this is our ERD. ERD means intensity relationship diagram. It's like the intensities and the attributes and their relationship between the entities of our whole system. First, we have this entities. First is patient, then we have a dermatologist, and then patient will create cases, and the dermatologist will like create derm review, and the patient will like upload patient images, and then after that, the cases will generate a report. And also we have skin conditions, this entity, and also we have a chat. Case is the most important entity. I think everyone others entities have this as a F key, and patient and the dermatologist is the foreign key of the chat, and also derm review has a foreign key of the dermatologist, and also the skin condition. That skin condition is a list of our skin conditions. And about the report, also it have a foreign key. It's related with the case, and also patient image will upload by the patient and related with the case. Yeah, that is our ERD.
Yes. So coming to the state diagram, here first we have to open the case. Like with this, the user opens a new case by uploading an image of the skin condition. So after uploading the image, the AI analyze the uploaded image and gives the output, and after completion of AI diagnosis, um it provides an initial diagnosis, moving to um uh, what is that, a requested chat or a request review. So after that, chat open or chat closed, we can use a requested chat, or the process moves to chat open, or once the chat ends, the state transits to chat closed, and from there the system generates a report and closes the case. So coming to under review or reviewed, if the user requests a reviewed, the process it will go through under review or reviewed. So after dermatologists complete their review, the state moves to the reviewed um option. So at this point, the system generates a final report and the case is closed. So after the case closed, in the both cases, whether the chat ends or the dermatologist reviewed is completed, the system generated report and transit transmits a case closed, and like and the process will ends. Yes.
Yeah, hi. This is the concept diagram of our project. Let's see the workflow of concept diagram. First, patients uploads images of the skin condition. Then the AI model processes the images and provides an initial diagnosis. The patient then receives the AI diagnosis and can request further insights from a dermatologist. The dermatologist reviews the diagnosis and adds comments and consults with the patients through chat system. Both the AI diagnosis and dermatologist review are compiled into a final report which is provided by the patient, which is provided to the patient. Next, please.
Hello everyone. This is a class diagram. So let's overview the class diagrams. So over here, the key classes are patients, medical professionals, prediction, image upload, and chat. The patient can handle image upload and access the prediction, while the medical profession allow doctor to review the diagnosis, and the prediction manage the diagnose uh, process and linking the patients and the doctor. And the image upload stored the process the image submission for the diagnosis. Finally, the chat class facilitate the communication between patients and the doctors. The class work together to provide a seamless process for diagnosis, skin conditions, and supports the patient's doctor interactions. Next, please.
Yes, so this is the entire product backlog. So let me just give you all a brief explanation on these user stories, acceptance criteria, the features they belong to, and the story points our team decided. Uh, yeah, so the first user story, that is the image upload feature. As a patient, I want to upload an image of my skin condition so that I can receive a diagnosis. And the acceptance criteria for this is image selection, valid file formats, and submissions. Moving on to the second story. that is AI diagnosis feature. As a patient, I want to upload several images to one case so that I can provide more information. And the corresponding acceptance criteria is multiple images, valid formats, confirmation, and preview. The third user story is AI diagnosis feature. As a patient, I want to receive a diagnosis so that I know the skin issue I am facing. The acceptance criteria would be diagnosis within a minute. And moving on to the fourth user stories, that is also AI diagnosis feature. As a patient, I want to receive the most accurate diagnosis, and the acceptance criteria will be high diagnosis accuracy. On to the next slide. Yes. The fifth user story, also an AI diagnosis feature. As a patient, I want a brief description of the diagnosis condition, and the acceptance criteria will be clear language, symptoms, and causes. And sixth user story, also an AI diagnosis feature. As a patient, I want treatment recommendations, and the acceptance criteria would be clear language, symptoms, and causes. And moving on to the seventh user story, that is a report feature. As a patient, I want a comprehensive report with all the details, and the acceptance criteria will be patient information, diagnosis, treatment, as well as dermatologist input. The eighth user story, that is the report download feature. As a patient, I want to download a comprehensive report, and the acceptance criteria would be downloadable. The report is downloadable in PDF format. Can move on to next slide. Yes, the ninth user story is related to user account management feature. As a patient, I want to view my past cases and track their status. And the acceptance criteria will be, there is a chronological listing of past cases along with the status updates. And the next user story, that is the 10th one, is also a user account management feature. Yes, 1 minute. Yes, as a dermatologist, I want to access and view patient report. And acceptance criteria would be view and sort reports by date, status, or patient ID. And the next user story, the 11th one, is dermatologist review feature. As a dermatologist, I want to add my diagnosis to patient reports, and the acceptance criteria would be dermatologist input associated with the report. Moving on to the 12th user story, that is also a dermatologist review feature. As a dermatologist, I want to add comments to patient reports, and acceptance criteria would be add text input with character limit. Moving on to the 13th user story, that is also a dermatologist review feature. As a patient, I want to be notified when my report is reviewed by a dermatologist, and the acceptance criteria would be notifications via email or in-app notification. Then next slide. Yeah, the 14th user story is a chat feature. As a patient, I want to chat with a dermatologist in real time, and the acceptance criteria will be real-time chat with typing indicators. And the 15th user story is also a chat feature. That is, as a dermatologist, I want to chat with patients in real time, and the acceptance criteria would be accept or decline chat request, send or receive text and attachments. User story number 16, 17, 18, 19, all are related to user account management features. Let's discuss it one by one. The 16th user story, as a patient, I want to register an account, and the acceptance criteria would be full name, email, password, date of birth required for registration. 17th user story, as a dermatologist, I want to sign up to access patient reports, and the acceptance criteria would be full name, email, password, and medical license number required for registration. Moving on to last but not the least user story, that is the 18th one. As a patient, I want to log in to manage my cases and view diagnosis. And the acceptance criteria would be the email and password required for login. And the last user story is, as a dermatologist, I want to log in to manage patient reports. And the acceptance criteria would be email and password required for login. Let me move on to the next slide.
Okay, everyone. Let's talk about what we did in the sprint one. In sprint one, we choose these two user stories to complete them. First is user story one. As a patient, I want to upload an image of my skin condition so that I can receive a diagnosis. What we should do is let patient can access an interface to upload an image. They can see an interface and they can see a button to upload an image. And when patients click this button, they can select and submit an image from their device. And the system should accept image files in specified format JPG and PNG like that. And the uploaded image should be stored and associated with the patient's case. And a confirmation message is displayed upon the successful upload, like if the image successfully installed in the our database or something, the patient should can see a message let them know this process is successfully. And the user story of this story, the story point of this user story is 13. And about the user story 3, as a patient, I want to receive a diagnosis so that I know the skin issue I'm facing. This one is the core feature of our whole project, the most important one. So it have 20 story points. Um, uh, After the submitting the image, the patient should receive a diagnosis. That's the most important thing. And this diagnosis should present it as the name of the skin condition. And the system should give the feedback in a reasonable time, like less than 1 minute. We can see the AI model running for 20 minutes and the patient waiting for the diagrams for 20 minutes. That's all.
Yeah, hi. Now let's discuss the test cases we have designed to verify that the features worked as expected, providing patients with a smooth experience when uploading images and receiving diagnosis. We also wanted to make sure that the system responds correctly under different conditions and edge cases. As Luven also discussed the user stories of Sprint 1, as a patient, I want to upload an image of my skin condition so that I can receive a diagnosis. So for this, we have divided many test cases to test this user story. Let's see. One, access image upload interface. So for this, we have written the step descriptions, how to proceed to test this case. The patient is logged into a system or visit as a guest. To do that, he or she can navigate to the application's homepage, then click on Start Your Test option. So as expected, the case submission page is displayed, good layout and allowing the patient to select images to upload. And I have executed this test case on October 16 and it passed. Similarly, the test case 2 uploaded support images format JPEG. Next slide, please. Also, this upload supported image format PNG. It is also passed. and I proceeded this test case on October 21, and the test case 4 attempt to upload unsupported image format like GIF. Uh, it the as expected system displayed an error message unsupported file format. We can upload only two JPEG or PNG image. It is also passed, but we we did not do one feature in this sprint, the which is test case 5 attempt to upload without selecting a file. We will do in coming sprints. So yeah, this is one of the sprint backlog we have now. So yeah, next slide, please.
Oh, hello everyone. So I will briefly overview the test cases of user story third. So where the goal was the patient to receive a diagnosis based on the uploaded image of their skin conditions. So the test was conducted on October 21st. So I have tested the four cases and here are the titles. So first one, successfully diagnosis delivery by the image. So I have tested this and the test result was passed. Second one, the diagnosis presentation formats. So and the test result was passed. Uh, Next slide, please. For the third test, uh, timely diagnosis delivery, and the test result was passed. And the fourth one, the test result is defeated because we cannot completed the this feature in this sprint. So we will address in our next sprints.
Yes. Here, we used like sprint one user stories. Um, like I'll tell you one by one. So what we did is like as a patient, I want to upload an image of my skin condition so that I can receive a diagnosis. So here we set up a React plus with front-end server and set up Flask backend server and finalize a Figma design for sprint one. And we create a React front-end for homepage, and we create React frontend for image upload page too. So for this one, integrate the front end and back end for image input. We can, unfortunately, we didn't complete it, but we can do this one in the next sprint. And coming to user ID 3, as a patient, I want to receive a diagnosis so that I know the skin issue I'm facing. And here we got like 20 story points, and this one we did a query data set and format labels, and we pre-process the images, and we develop the training file on the collab, and we deploy the model to the cloud server, and we evaluate and inference of the image classification model and integrate the image classification model and backend. In this user ID, we didn't complete deploy the model to cloud server and integrate the image classification model and backend. So these three we can do these on next sprint. Yes, and we completed like everything, but these three is like a subparts. Yeah.
Okay. For Spring 1, our team successfully complete 27 story points. And overall, what we have done make us have a strong foundation in place and are on track for further development. Goodness.
Hello everyone. This is our Bundan chat for the Sprint 1. The duration of our development is about 16 days, and we have 33 story points in the sprint one. So the green line is the expected story points we plan to do the remain and against to the time remain. And the right line is the real what happened. With a little bit delay from the expected timeline. And at the end, we still remain, I think maybe remain 6 story points we didn't complete it in the sprint 1. And about the committed ratio, we planned 33 story points in sprint 1, and what we finish in the sprint 1 is 27. So the committed ratio is 82.
Abhi, you can speak.
You're muted.
Hello, everyone. So let's come to the retrospective. So in this, we have take the 10 minutes to write the each sections. After that, we have voted, and then we have written the actionable items. So over there we discuss what will write if we were to do it again. So what will we do differently, and identify the actionable items that help us to improve the future sprints. This will give us chance to celebrate our success and learn from any challenges we encountered. So let's discuss the few important points of retrospective. So let's go on to what did we do it right. So first, Leslie, let's read.
Okay.
Yeah. Okay. So first, Scrum meetings are going well. So our daily Scrum meetings have been effective. Everyone has actively participated, and we have been staying on the track with our updates and progress. Second one. So if anyone couldn't attend a meeting, then they provide a valid reason beforehand, which help keep communications, transparency, and maintain the team coherence. Third one. So each team member took uh, initiative to do research for the parts they were responsible for. This research were very insightful and help guide to development process, give us a better understanding of the challenges that we are facing. And the fourth one of the biggest positive has been the team willingness to help each other wherever someone face an issue. Other work quickly to offer assistance. This really speed up the problem solving and keep our progress moving forward. So let's come on. If we were to do it again, then what will we do differently? So let's come on the first point. Breaking down tasks into smaller sub-tasks. So we found that some of the tasks were too big and broad. So by breaking them into smaller and more detailed subtasks, we can make them more manageable, easier to track, and less overwhelming for each team members. Then come to second point, better focus on current user stories. So we spend lots of time discussing the project as a whole, while end up in consuming more time than expected. So while it's important to have a big picture view, we can focus more on user story assigned for the sprints to avoid the running out of the time. Then we come on to the third point, start coding earlier alongside with research. So in this sprint, we spend lots of time on researching before we start coding. So next time we could balance this better by starting the coding process earlier in the parallel with research so we don't lose valuable development time. And the fourth point is more quicker decisions. So we notice that sometimes a lots of time we spend uh, each other and trying to align on discussion. In future we could speed up the process by making decision, perhaps using a voting system to resolve the disagreements efficiency. And the last point is set up deadlines ahead of time. To avoid the rush towards the end of the sprint, we could set up initiative deadlines a day or before the actual course deadlines. This would give us a handle and last minute issue that might come up. So let's come on actionable items. So as we discussed the previous section, from that we choose the few actionable items. So the first one is Z will take the lead on breaking down the tags into smaller sections, more detailed subtasks, so they can is easy to manage. So and everyone will responsible for keeping the updates while developing the ensure we all aware of process and potential progress. And second one is Pujita. We'll keep discussing, focusing on the current sprint user stories, making sure we don't spend too much time on broad project discussion. Third one, like everyone will start working on development in parallel with the research so that we don't delay in our uh, code perhaps. And the Tanzil will have to manage the discussions. If we encounter disagreement, then we will use a voting system to make a quicker decision and avoid spending too much debates. And the another one is the Bangling will set initiative deadlines 1 or 2 days earlier that the actual course deadline to ensure we have time to resolve last minute issue. And the last one is Zoan will create a checklist to help tax process so we have a clear view of what's tax and what will still pending. And the Z will continue next.
Continue.
So yeah, this is the screenshot of our Sprint one retrospective idea board. You can move on to the next slide. Yeah, Pujita, you can.
Yes. Um, so before, like after, like we are going to do the sprint to planning. So we use we did some user stories. So like coming to the sprint one, we did each and everything like as a patient, I want to upload an image of my skin condition so that I can receive a diagnosis. So this is the main user story in sprint one. So in that we didn't completed like a subpart in the sprint user ID one. So like like uh, integrate the front end and back end for image input. That one unfortunately we didn't complete it yet. We can do it in the next sprint. So coming to the user ID 3, as a patient, I want to receive a diagnosis so that I know the skin issue I'm facing. In this is the main one. In this, we didn't complete like a two subparts, like a deploy the model to cloud server and evaluate an inference of the image classification model. For example, I'll tell you, um, if if any user upload an image, if he like a user didn't select any image but it click on like a submit, it will give it will gives like error, like a warning, like you didn't upload any image like that. But that model we didn't complete it yet. What it is coming is, if any user didn't select and submit it, it doesn't show up anything. So here we did like a main user IDs. Like as a patient, I want to upload an image of my skin condition so that I can receive a diagnosis. And user ID 3, as a patient, I want to receive a diagnosis so that I know the skin issue I'm facing. These two parts, we have a sub parts we didn't complete it yet. We can do it in sprint 2. So those are like integrate the front end and back end for image input and deploy the model to cloud server and evaluate and inference of the image classification model. So, and we have user stories for sprint 2. So, as a patient, I want to upload several images to one case so that I can provide more information about my skin condition. And as a patient, I want to receive the most accurate possible diagnosis so that I can trust the diagnosis provided. And as a patient, I want to receive a brief description of the diagnosis condition. Then I can understand the skin issue, what I'm facing. And as a patient, I want to receive treatment recommendations so that I can take action towards treating my skin condition. And as a patient, I want to view a comprehensive report of a case so that I have a complete record of my skin condition assessment. And as a patient, I want to download a comprehensive report of a case so that I can keep the document of my skin condition assessment. So these are like we are going to do it in sprint 2. Yeah. And this is a screenshot of our project.
Yes, you can move on to the next slide. Yep, so let's talk about the APIs we have in our sprint 1 up until now. So the endpoint slash predict, it's a post API. So this endpoint accepts an image file uploaded by the user from front end. The image is sent to Flask backend, which processes it through a machine learning model and returns a diagnosis. The request is a post request where the image is sent as form data. The response is a JSON object containing the diagnosis result, such as the identified skin condition, and Axios for API request, which I already discussed. And then we have cross-origin resource sharing, which I already spoke about. And then the last model prediction. The image is processed by machine learning model in the Flask backend, which analyzes it and returns a skin condition diagnosis. Then the prediction is sent back to the front end where it is displayed to the user. Next slide, please. Yeah, so these are the screenshot from our code. The first the screenshot on the left side uh, uh, has a code of a Flask API, and on the right side it is a front end Axios. So we can move on to the next slide. Yep. So to see our progress, like up until now, what are all the deliverables we finished and completed, you can visit this link and view our progress. We go to the next page. Yes. So let me share my screen for the demo. Is my screen visible?
Yeah.
Yes.
Okay. So let me run the front end, React front end, as well as the Flask backend. So yes, so our both servers are running now. Open a new tab and go localhost 5173. So yeah, so this is the front end of our SkinLens app. As Bangling mentioned in the project design, we have all the instructions on how to upload an image, how the AI analysis work, and how we get results. And this is the home page, and if we can click on upload, it takes us to an upload an image page, as well as you can click on start your test on the home screen. It also takes you to upload your skin image. So let me input three different images and show you guys the expected results. So yeah, once I click on click image, it opens, it allows you to choose a file from your system. So let me select this file, which is a JPG format, and when I click on analyze image, yeah, we get a prediction result, that is dermatofibroma, which is a harmless skin trauma. So let me select another image, which is also a JPG format image, and when I click on analyze image, yes, so the predicted result is melanoma, which is a serious skin cancer. So let me select another image, a third one, and click on analyze image. Yes, so the prediction result is actinic keratosis, which is caused by intense UV rays. So as of now, we have implemented only the image upload feature and getting an output, and the rest features we are going to work in the upcoming sprints.
Okay.
Thank you.
Okay,
Thank you.
thank you.
Thank you.
Thank you.